So from there, let's take a look at the actual IP header itself. Now, the IP header itself is broken down into 5 words, possibly 6 words, depending on if you have the options field. And I don't show the options field inside of our example here, but there's another field at the very bottom of this where you actually add additional options like IPsec for VPN things and so on. So a word is 32 bits in length. And we see the numerical value at the top from 0 to 31, so a total of 32 bits. And as you take a look here, the first field is the version field. So currently we're running version 4, and that's what this header corresponds to, is the version 4 IP header. And then you have the header length field, the TOS bits, or type of service bits. We use that in the QoS portion of the header to determine what packets are more important than other packets. Effectively, real-time traffic should be going in front of non-real-time traffic, etc. We then have the total length. That's the length of the header plus the layer 4 header and the data portion as well. The next 3 fields, identification, flags, and fragment offset, are there in case we have to chop up the IP header in transit. We can take it, we can put it back together based on these 3 fields. The next word starts off with the TTL field, the time to live field. This is a very important part of the IP header. The time to live field has a maximum value of 255, and then every time it goes through a router, it decrements that field by 1. Now, depending on the application that you build, it's going to use a TTL field of a certain value depending on the application. But the interesting thing about the TTL field is that the TTL field is what's used to make sure that we don't have IP packets floating around the internet forever. I mean, really the internet as we have it today, version 4, has been around since the early 80s. Without the TTL field, there would still be packets floating around the internet that's been there for 20-something years. So the TTL field keeps us from having packets that are looping back and forth, and we discard them once they hit 0. It's also, case in point, we'll talk about this later, it's how the program traceroute works to determine how many router hops away you are from a particular destination. The protocol field identifies the header that's going in the layer 4 portion of the overall packet. So the protocol field will identify the type of header that's at layer 4, whether it's protocol 1, which would be ICNP, Internet Control Message Protocol, or 6 for TCP, or 17 for UDP, are 3 common protocol numbers we'd see there. Don't confuse this with a port number. So like port 80 is actually the port number that shows up inside of the TCP header, not the protocol here, which would identify that it's actually TCP running at layer 4. We then have a checksum, again a sanity check to make sure the header's okay, and then 2 32-bit fields for a source address and a destination address. The actual format of the IP address, broken out into binary, is broken out into 4 bytes. Now, what's interesting is they actually call these 4 octets. And the reason they don't call it a 4-byte number, because again, if you go back to the early 80s when IP version 4 was first invented, a byte wasn't necessarily always 8 bits. You could go to, certain boxes would use a 7-bit byte with a 1-bit parity, or other boxes would use a 9-bit byte. So a byte wasn't always 8 bits, depending on the platform you were dealing with. Today, a byte is 8 bits, and pretty much, if it was invented today, we'd call this a 4-byte number, not a 4-octet number. But that in case we're using the old nomenclature for what an IP address format is, so we call them 4 octets. Now, if you take the binary and you break it out into decimal, because we usually work with IP addresses in decimal format, this binary would break out and become 192.168.1.14, which is the notation we'd use to assign an IP address to a device. Now, later on, we'll talk about how to convert our decimal and binary stuff, and we'll deal with the control mechanisms we can do within an IP address as far as controlling the network and host portion of the address, doing subnet masks, and so on.